Hi, I'm Rob Richardson. Let's dig into making Kubernetes how we build things. There's no slides for this talk. It's all live demos. Let's dig in. We're going to talk about lots of tools that allow us to work with containers as we're developing. First up, I have here a container that I've built based on this Docker file. It's running this web server. Now, we can start to do things like Docker build. I don't even remember all the commands. Maybe there's a -t and apparently I need a dot. After I remember all those things, now I need a Docker run and hello node v0.1, and now I need some -p, except for it doesn't go here, it goes here. If only I had a better way to remember all of these things. That's where we have a Docker Compose file. Now you may have looked at Docker Compose files in the past. Let's look at this one in particular. Now this Docker Compose file very specifically says network mode bridge. So we're not going to create that overlay network. Rather, we're just going to take all of the build and run parameters right here and actually execute that content. Docker Compose up, and now it starts up that container. Now in this case, I've already built it, so it's not going to rebuild it, but it spins it up really quickly. And once it's running, I can now hit localhost :3000, and I see my website. Very nice. I didn't have to remember all of the particulars about starting and stopping. I just remember Docker Compose up and everything works. Let's say Docker Compose down, and now it'll take down the website together with all the dependencies. If I have multiple dependencies within my application, maybe I have one Docker Compose file for my application and another Docker Compose file for my data sources or external resources, this network mode bridge is really helpful in being able to identify the content that we need and start up only those pieces, allowing all of the things to talk to each other. If I'm working on my backend, maybe I only need to spin up the Docker Compose for my dependencies, and I'll run the rest of my app locally. Next up, let's take a look at running Docker differently. Now, Docker creates OSI compliant images, and we can run those images anywhere where an OSI compliant mechanism runs. For example, Kubernetes. Now, I can come in here into the Docker settings and just turn on Kubernetes mode. That'll definitely do it. But let's look at an alternate runtime. We can look at Minikube. Minikube is an alternate runtime for running Docker, and I can just say Minikube start, and away we go. Here inside Minikube, I have a virtual machine running Kubernetes. Here's that Minikube virtual machine. And so you notice that I didn't go to localhost :3000, but rather Minikube :3000. Minikube is a great way to be able to spin up an alternate Docker runtime. Now, once I've spun that up, I can come in here and I can say Minikube Docker env, and it will spit out the environment variables that I need to be able to connect from the Docker command line to any system to this Minikube environment. So I'll just go grab all of these environment variables, set them in place, and now Docker image list or Docker container list, I can see all of the content in my cluster just fine. Now what's interesting is we're showing all of the Kubernetes control plane cluster containers as well. Now in Docker, we can quickly disable that just by checking this box that says show system containers. In Minikube, it's the batteries included version. So when we say kubectl get all, we probably want to pipe it to grep-v k8s. And that will remove all of the system containers if we need to. Why would I use Minikube? It does nested virtualization really well, and I can do this, Minikube SSH. I'm now in the server. Docker Desktop very specifically locks us out of the server. Now I can get in the server and I can start to look around. Minikube is a really elegant mechanism for being able to do content like this. Next up, let's look at rebuilding quickly. Now, ideally, I want to do something like Docker watch and have it just watch my source code and rebuild the application anytime I need to. I can't do that, but I can do scaffold dev. Let's take a look at scaffold. Scaffold dev. Scaffold is a really elegant tool that allows us to be able to automatically watch content, rebuild a Docker image, push that to a container registry, and start up a Kubernetes resource. Once we say scaffold init, it will build up this YAML file that allows us to get started really quickly with scaffold. I already have a scaffold file right here, and here's that scaffold YAML file. It's going to build the hello node image. It's going to then start this Kubernetes YAML file. Now this Kubernetes YAML file specifies v0.1, and as it rebuilds, it will overwrite this image name with the image name that it just built. So here I am. I've got my server running on port 3000, and let's come in here to our content and let's change something. Instead of saying hello world, let's say hello scaffold. I push save, and it goes and rebuilds my container, and it could automatically push that to a registry. In this case, I've chosen not to, and automatically restart my app. And now kubectl get all. I will get this pods or this services node port, and now I can go to minikube : that port, and I see my new application. There we go. Hello scaffold. Perfect. So let's jump out of scaffold and take a look at the next piece. The next piece is visualizing our images. Dive hello node v0.1. Let's take a look at dive. Dive is a really elegant mechanism to be able to discover content within containers. Now we could use Docker history and be able to see the commands run, but it is really, really interesting to be able to explore all of the layers of our image and understand what we need to do differently. So we've got this image ready to go, and let me get to the spot where I'm actually building it. Here's workdir app, so we see this app directory appear. It's green in this case. Let's close these directories. And let's go to the next directory where I do the copy in all of the content. We can see that we got our server.js, but we also got some stuff that we didn't expect. That's really good to know. It looks like here in my application, I forgot a Docker compose file. Let's create a new Docker ignore file. Docker ignore. Here in my Docker ignore, I'll ignore Docker file and Docker compose.yaml. And now I've been able to discover the content in each layer and be able to optimize it. That's cool. Dive is really elegant for doing that. Let's take a look next at lazy Docker. Like visualizing containers, lazy Docker is a great way to visualize clusters. Now I love how they're clicking through each of the images, looking at all of the logs and stats, and it's a really elegant live experience. And unfortunately on Windows, Windows doesn't allow clicking. So we're not going to get a whole lot of experience here, but we can walk through a little bit and get a feel for some of the stuff. Hello Docker. Lazy Docker is really interesting for visualizing from the command line. Let's visualize instead from Portainer. So I'm going to say Docker compose up, and let's go look at Portainer. Portainer is a really elegant way to visualize our Docker cluster visually and take a look at all of the content involved in our cluster. Now that we've got our container running, actually, let's go look at the docs where we identify this Docker compose file that allows us to do all of the things. Now it very specifically maps in the Docker socket and launches Portainer on port 9000. So let's go to minikube 9000 and we'll get to look at our content. I haven't logged in yet, so let's give it a password. Password, and now we're logged in. We could choose to use Portainer to view a cluster on a cloud or connected to a remote agent. In this case, we'll use the local Portainer thing. It identifies that we need to map our socket. We've already done that. And now we're here. This is our cluster. As we look at our cluster, we can see that we've got one stack running, we've got 30 images, 4 networks. Let's take a look at those images. Here's all of that content that's running. That's cool. Containers. Now we have all of our Kubernetes content going. Let's do this. Docker run -p 3000. Hello, node. And we'll launch this extra container. Now that I've got this extra container here, let's push refresh. And we can see there's that, nope, it didn't launch yet. Is it on its way up? Server is running. Okay. There we go, 3000 to 3000. So here's our hello node image. It's running this container, and we can start to dig into this container and learn a little bit more about it. If we want to grab the console logs, here's the console logs that we saw in our console, but we can also harvest them here. We can take a look at other details like inspect and see all of the different configuration details, digging in to the particulars of that object. If we want to, we can look at the console. Now in this case, it's built on Alpine, so I'll switch over to Ash and I'll connect. pwd, uname -a. I'm actually inside this container. Let's take a look. We have that Docker file and Docker compose file. I definitely need to use scaffold to be able to automatically rebuild that image now that I've modified the .docker ignore file. And let's cat server.js. Okay, so now I can understand what I've got going in this container, and let's exit back out of it, and I'm all done. When I'm done, let's remove this container, and now it's no longer running in our cluster. Portainer is a great way to visualize the Docker side of things, understanding containers, images, volumes, networks. Let's look at now how we might look at this using a Kubernetes mindset. So let's jump out of here, Docker compose down, and kubectl apply -f k-. K- is really an interesting way to be able to visualize a cluster in Kubernetes metaphors as opposed to Docker metaphors. We'll look at pods and services and understand that content. Let's do a kubectl get all and find the node port for this service. Here we go. And now here in k-, we can go to minikube that port, and we're asked to log in. Now I can go grab that secret from my secrets as I created this piece. Let me paste that secret into place. And now I am logged into k-. K- allows me to visualize my cluster in Kubernetes mode. Here's nodes, pods. Let's dig into namespaces, default. Right now I don't have anything running in the default other than k- itself, but we can take a look at that pod and understand the details associated with it. Jumping back up to my cluster, one of the things that I like looking at is here in storage, I can look at volumes. Now in this case, I don't have any volumes, that's good, but volumes tend to, well, gather dust. Let's come out here and we'll go into accounts and look at secrets. Wow, I've got quite a few secrets in my cluster. Did you really expect to have that many secrets in your system? Well, here's the one k8-. Here's the token that I use to log in. Now, in this case, this token is specific to my instance of k8-, and I'm running on a local cluster that is not exposed to the internet. But there's the secret. Actually, that's the certificate. Here's the secret. Here's what I pasted into place when I connected to this dashboard. Now, ultimately, that's kind of a lot of secrets. Did I need this many secrets? Okay, so let's pop out of K8-, kubectl delete. Oh, not here. Right here. Kubectl delete -f K8-. Now we've gotten to look at ways to visualize containers, visualize our cluster in both Docker mode and Kubernetes mode. We've looked at ways to be able to visualize a container, to quickly rebuild a container. Now let's look at ways to debug a container. Let's come in here to 6. Now I have, actually let's start it this way. Open with code. I have a container here that, or an application that I've built here, and inside this application, I have the regular content, but then I also have this .dev container folder. Inside this .dev container folder is this dev container.json that allows me to launch this as another container. Now, I could definitely come in here and let's come in here. So how did this work? Well, I started off by installing the remote containers extension. It's actually part of the remote development pack. So with the remote development pack, you get WSL, remote containers, remote SSH. The remote containers one is the one that I'm using in this case. I could come in here to the green spot, and I can go to here and I can say try a sample. This will allow me to pick from various languages so that I can use a sample within my chosen language. Alternatively, if I have a particular application that I'm looking for, I can say add development container configuration file, and that will get me the pieces that I need. Now, as I'm doing this, it's actually going to split VS Code in half. Half of VS Code is running in my local environment, half of VS Code is running inside the container, and there's this port and volume mount between them. So now that I'm here inside my container, I can take a look at the content in my container. Uname -a, I'm really in this container. Now here's that dev container.json that explains the particular details about how I wanted to launch this. Now in my case, I'm using Minikube, so I need to bind my workspace a little bit differently, but I based off this Docker file. Here's that Docker file, and it's just a standard Docker file. I chose to install Git in case I want to do some Git details. After it runs, I want to identify these forward ports. I could choose to have a post create command npm install. And now I can start by, well, let's set some breakpoints in our application and take a look at it. I'm using standard VS Code debugging mechanisms. And now when I launch inside the container, it'll automatically proxy that port back to my local machine. What's that port? Well, the port running on my local machine is, the port running inside the container is 3000, but let's continue on and we'll automatically get that port proxied. Ooh, VS Code noticed that I launched it. Let's open in browser, and you'll notice that we're not going to minikube :3000, but rather localhost :3000. This is a proxied port into that particular cluster. So whether you're running on Minikube or Docker Desktop or inside AKS or GKE, you can get at the containers that are running and debug them in context. It looks like we hit another breakpoint. Now we're here inside of our server and we can do all of the normal things. We can mouse over and look at variables. We can come in here and identify the details associated with that request. In this case, I'm going to push play, and now we're loading the icon. Push play, and now we've got our service. It's really helpful to be able to debug inside containers. Now, once I'm done, I just come back here and I say close remote connection, and I'm all done. Now, what we saw was really elegant mechanisms to be able to debug in containers, to visualize clusters, and to be able to visualize clusters both in Docker mode and in Kubernetes mode. Start differently using Docker Compose, and even run alternate Docker runtimes like Minikube. Tweet me at Rob_Rich, and let's continue the conversation. Thanks for coming.